Hey guys, and welcome to today's lesson on Newton's laws. So we're going to be looking at an introduction into forces and all of the different applications thereof. So what is a force? So remember last year we did vectors and scalars. So a force is a vector quantity that causes an object to move, change shape, or change its state of motion. Alright, so the sign for force is F, and we always measure it in newtons. The sign for newtons is just N. The formula for force that we're going to be using in the beginning is F is equal to M times A, where my mass is my mass, always measured in kilograms. Remember, in chemistry it's measured in grams, but in physics it's measured in kilograms. And then my acceleration, and that's measured in meters per second minus 2. This is also a vector quality, so therefore it also needs magnitude plus direction. Alright, then we get different kinds of forces. We get contact forces. So a contact force is when the object has to be in contact in order for the force to take place. And these would include friction, tension, normal force, and applied force. Those are my contact forces. And then my non-contact forces include gravitational force, and electromagnetic force. Okay, now before we delve a little bit deeper, I just want to go talk to you guys quickly about friction. So what's important about friction is it's always in the opposite direction of motion. So if I have a box and I push it this way, my frictional force will always be in the opposite direction, right? We get two different kinds of friction. We get static friction and we get kinetic friction. So static friction is the friction that acts on this on the object when it is still, so when it's not moving, when it's stationary. So very often the object has to overcome the force of static friction. So my applied force needs to be bigger than my static force in order for the object to move. My kinetic friction force, that is the kinetic friction that acts on a moving object. Both of them are still in the opposite direction, okay? And you guys are going to learn a little bit more about how to calculate friction this year, but friction force is equal to mu times my Fn. So this is a constant. It's the constant of friction, and my normal force is obviously my normal force. We're going to talk about that now. Okay, so that is friction force. The other one I want to talk to you guys, okay, tension, you know, if you have a string, so let's say you have a box over here and you have a string pulling over there, this force that's happening in the string over there, that's pulling the string, or pulling the box rather, that is my tension force. Then we get our normal force. So my normal force is the force of the earth on the object, right? So let's pick a nice color. So my normal force is Fn, and it is always perpendicular to the surface. Okay, so what that means is if my block is like this, right, and it is on the surface, there's no inclination or anything, it's just straight on the surface, my FG is going to be, my FG is always straight down to the center of the earth, and my normal force is always perpendicular. So my normal force is going to be upwards over here. It's perpendicular to the surface. Okay, so I'm happy with that. Because there is no lifting or lowering, my Fg in this case is equal to my Fn. And if we remember, our Fg is equal to mass times g. On Earth, the gravitational acceleration force is 9.8 meter per second minus 2. Alright, so if you have that information, you can go and calculate your gravitational force, and that's going to be equal to your normal force in this case. Right, however, if my box is being lifted upwards, right, my Fg is still going to be down this way. My Fn is not going to be perpendicular, well, it's not going to be just straight up anymore, because now my box is being lifted slightly. So now to get my Fn, it's going to be equal to my Fg minus my Fy. So what do I mean by that? Well, my Fg is going to be this value over here, and my Fy is going to be that value over there. So to get my normal force, I have to minus those two from each other. Alright, if I'm pushing down on my block, then my Fn is going to be equal to my Fg plus my Fy. My Fy I would go and calculate with trig, right? We're going to be doing a lot of trig. Okay, and we'll do a few examples of those in just a second. Then the other thing that we need to keep in mind is the inclined boxes. So when you have your box on an incline like this, right, they'll tell you, for example, this is 30 degrees, it could be anything. To get your normal force over here, my Fg, remember I told you, is always straight down. Okay, that's always my Fg. My normal force is always perpendicular to the surface, which means it's going to be over there. Okay, so what I do is I just extend my Fn. Okay, so this is my Fn going up here. This angle over here will always be equal to that angle over there. Right? And to get my Fn, it's going to be equal to my Fy, because it's just in the opposite direction. And this is my Fx. So my Fn, my normal force in this case, is just equal to my Fy. Alright? And that is going to be equal to my mass times 9.8. So basically my gravitational force times by, and then we have over here, this is a cos, right? Because it's an adjacent and a hypotenuse, times cos 30. And that is going to give me my normal force, okay? Anytime there's horizontal, this is quite important, we'll talk about this again, but anytime there's horizontal movement, in this case you're going to be working with Fx, which is going to be equal to sine 30, because now if you want to calculate this, it is opposite, so therefore you're going to be relying on sine to do that. Alright, so that is normal force. Then gravitational force we spoke about. Okay, let's quickly go have a look at the three laws of motion, or yeah, the three Newton's laws of motion. The first law is the law of inertia. And what this law says is that an object remains at rest or in uniform motion unless acted upon by an external force. Okay, so the law of inertia says that something is going to keep moving, or it's going to keep staying still, unless there is a force that acts on it. So An example of this would be in space. When a rock starts moving, it doesn't stop moving because there's no wind resistance or anything that works against it. The only reason a ball on Earth would stop rolling is because of the friction and the wind resistance that slows it down. But in space, for example, it will keep on moving. Another example is if you're sitting on the couch watching TV, you're going to continue sitting in front of the TV, the TV, unless your parents come and tell you have something to do. So there's a force that acts upon you, and then you'll get up and go do something. Right, then my second law of motion says that my force equals my mass times acceleration. So this formula we looked at earlier, this is the formula that comes out of the second law of motion. Alright, and it's measured in newtons. We know force is measured in newtons, but there's another thing it's also measured in, and it's measured in kilograms per meters per second minus 2. Alright, so that is another unit that you could use. Okay, so that's, for example, if I have a car. So let's say I have a car here, and my car weighs 100 kilograms. And it accelerates at a rate of 3 meters per second. The force is going to be, I'm always going to write down my formula so that I can get marks for that. In the original direction. Okay, I'm giving my direction because it is a vector, and with a vector I always have to give the direction as well. Alright, then let's go have a look at calculating net forces. Okay, to calculate the net force, we're going to say F net is equal to force 1 plus force 2 plus force 3, how many ever forces there are. What is important is, number one, that my forces must be in the same direction. And if they are not, we have to change the sign. And also, I can only add or subtract forces that are on the same plane. Okay, so what do I mean by that? If I have, let's say this is a box, and I have a force going in this direction, and a force going in this direction, and another one going in that direction, and this force is 100 newtons, this one is 20 newtons, and that one is 60 newtons. In order to calculate my F net, I'm going to say F1 plus F2 plus F3, and then I have to pick a direction. So here at the top I'm then going to say let right be positive. This is for me to know when I get my final answer when it's positive or negative. There's no such thing as a negative force. It's got to do with the direction. So if I have a negative, it means it's in the opposite direction to the one that I chose as positive. So that's why I write this over here, so that I know when my answer is positive or negative in which direction it moved. So I'm going to say F net is equal to my first force, which is 100, plus my second force, which is 20, minus 60. So my answer is 60 newtons. My answer was positive, therefore it was right. Okay, to the right. So that's how I would do that. The same thing if I have a force going up and a force going down and a force going right and a force going left. Okay, so now it gets a little bit more complex, because let's say this one over here is 100 Newton, that one over there is 40 Newton, that one over there is 80 Newton, and this one is 20 Newton. I cannot go and add all four together because they're not on the same plane. So I have to break my motions down to up and down. I mean up and horizontal. Let's make this horizontal, and let's make this vertical instead of up. Okay, Now with vertical, I'm going to choose up as positive, and with horizontal, I'm going to choose right as positive, just so that I know. Now I'm going to go look to at all my verticals. So I'm going to say F net vertical is equal to force 1 plus force 2. So that's going to be 80 minus 20, because I chose up as positive, which means down is going to be negative, which means my vertical force is going to be 60 newtons up. Okay, then my horizontal, I'm going to say because it's in the opposite direction, it's going to become a negative. Okay, so now I know that my force moved up and it moved right. Okay, now to calculate what my resultant force is going to be, my total final force, I'm going to go draw a triangle. So I know that it moved upwards and I know that it moved right. Okay, so it's gone up and right, and I'm going to connect that line over there. This is going to be my FR. What I'm going to do now is my horizontal, I'm going to make 60 newtons, and my vertical is also going to be 60 newtons. Now I can go and use Pythag. So now I'm going to say FR squared is equal to Fy squared plus Fx squared. And then I'm just going to get my answer for that and put it inside a root. Okay, and that is how to do it when it's not in the same plane. Okay. Let's go have a look at some examples. Let's go work through some examples. Okay, so they say it was an object of a mass 10 kilograms is on a flat horizontal surface and is being pulled up by a force of 100 newtons at an angle of 30 degrees. We need to go and calculate my normal force. So what I'm going to do is I'm going to go and draw this. I'm going to go represent this. Okay, now I'm going to close this up because they tell me it is done at an angle of 30 degrees. So I'm going to put my 30 degrees over there. And then I need to go and calculate my Fn. So remember I said to you with this one, because it's being lifted up, my Fn is equal to my Fg minus my Fy. Alright? And my Fy is obviously going to be that component over there. So in order to get my Fy, I'm going to say 100, its opposite, so it's going to be sine 30. And I get 45,399. Remember, we don't round off in sines up until the last step. So I'm going to write that over there. And then my Fg, remember my Fg is equal to my mass times 9,8. So let's go write down the equation for this. and there's my normal force. Right, let's go have a look at another one. Okay, now it's the same question. So once again we have a box and it is on a horizontal surface, but now they're saying to you it's not being lifted, it's being pushed. Okay, so where this is 10 kilograms, the force that's being applied now is 100 newtons. Right, so remember I told you guys with my normal force for this one, it is my Fy plus my Fg. And the reason for that is there's now an additional force that's being pushed down on it. So I'm going to write my Fy is still going to be 100 sine 30. Let's make that 30. And then my Fg is still going to be that, which means my final normal force is going to be that. Right. Let's go have a look at when it's on an inclined plane. If you have to calculate the normal force for this one, the first thing we go and do is we draw in our triangle. You need to remember that your Fg is always your hypotenuse in trig. Alright, so you always remember that that's the hypotenuse of the triangle. Even though it doesn't look like it, it looks like it's pretty perpendicular, but we treat it as the hypotenuse. Okay, so this is going to be my Fg. And this is my Fy. Remember I taught you my Fy is equal to my Fn. So when the previous questions it was added to my Fg or my, subtracted. In this case it is just equal to my Fy. Okay, so my Fy in this case, Fy in this case is adjacent. It's not opposite like in the previous example. So therefore we're going to be using cos. So we're going to say Fn is equal to Fg cos 30. So my Fn in this example is that. Right guys, I hope that helped and good luck for science.